We are going to just see what is a router. Okay. So we have already seen router in the previous class. So just a quick recap of that. So a router is basically a device or a hardware which is responsible for receiving incoming packets and just forwarding them to the other nearby router which connects one LAN to the other. The router is like a device or an interface which connects two LANs, two local area networks together, and it also enables different computers to connect to each other, right? The forwarding of data packets is done from one router to other. Basically it forms a network, and router always calculates the best path, which we will be studying in the next chapter, that is computer networks part 2. In that chapter you have a topic where we will be actually understanding the routing algorithm which is followed by routers. A router is mainly used in a LAN and wide area network, that is WAN domain. Data is transferred across network by using the routing protocols. Some of the companies that develop routers are D-Link, Cisco, Nortel, etc. So let me show you this image. You can see over here we have a router in between, and these are switches. Okay, these are the network diagrams or the network symbols, standard symbols for representing router and switch. Actually, the router or the switch, they don't look like this, but this is just a symbol, a standard symbol which is used to create a layout of networking. Okay, to create a sample layout, a prototype of a network, okay, on pen and paper. So for that we need very simple symbols which are easy to understand and comprehend. So this is a switch, and as you can see it is connecting four systems, four nodes, where three are clients. It is quite visible, and one has a hard disk extra storage space, which you can see, understand with the help of the cylinder icon. So you can just understand that this is a server, and this is a LAN, and which is connected together, held together by a switch, and this is another LAN which is held together by a switch, and these two switches are connected to a router. So you can see that the router is connecting two nearby LANs. Okay, so the router is an interface between two separate networks. And for our computer, our home computers, what is the router? It is the modem router which we are using, the Wi-Fi modem which you have with an antenna on it. Okay, that is a router, or sometimes we also, most of us own a Wi-Fi router these days, but a few years ago people used to rely on non-Wi-Fi routers, that is only which supported cable transmission of electrical signals only through cables. Okay, but now because of the Wi-Fi routers we are also able to connect all our wireless devices with the access point, with the internet access point. So this is the computer, this is a laptop, and either you can connect the laptop using the Wi-Fi adapter, the built-in Wi-Fi adapter, or you can attach a cable, an Ethernet cable, to this router. Now this is what, one second. Hmm. Now, sometimes, now usually our modem router, we call it a modem router. Why? Because that device serves the purposes of a modem as well as router. But certain times, some people don't have one of them, or in olden days, a few years ago, these used to be separate devices. Like we have the modem here, so you can see the modem is also connected to the router, and the computer is also connected to the router. Okay, so this computer is a node which is connected to the router, and this modem is actually an access point to the outside internet which is connected to this router. And you can see this, the point where this modem is connected, that point has been highlighted as internet. That is, this router is connecting two separate networks. One network is that of your host, which consists of your laptop. This is your laptop, and this is one host only. And here we have a router. we have a router which connects it to the internet, right? So this is a router. This is in case of home. Okay, the you can say residential premises have this kind of a layout or architecture, right? So basically router is what? It is a device which connects to separate networks, but those networks are not entirely different from each other. They work on agreed upon protocols. Next is we have, you can see over here, this is another example. Sometimes even a computer can serve as a router. Router is what? It is a network device. So we can either set a computer as a router, which will not be a dedicated router. It will be acting as a computer also, and sometimes it can act as a router also, depending upon its requirement. And sometimes you can also have a dedicated router for this purpose. So here you have, this router is connected to two network switches. This is one network switch, this is a second switch, and this network switch forms a small LAN consisting of three computers, and here also there is a LAN which could contain three computers or more, it depends. Okay, so this router is connecting these two LANs. This is LAN 1. So we can see that this is a LAN, this is a small network, local area network, and this is another local area network, and we have the internet over here, which is a bigger network, right? So this router actually does the work of connecting our LANs with a bigger network. Now, this is not needed in the modern setting because our modem is a device which performs the functions of a modem also, as well as a router. Okay, it performs the functions. Actually the modem is your LAN card which converts digital signals into analog signals, right? The task of modem is only that, and basically the task of this device is that of a router. Okay, next is what are gateways. Now gateways are, many times people confuse routers with gateways. They think that routers are like gateways or gateways are like routers. They have a lot of similarities, that is they do the work of connecting dissimilar networks, but there is a subtle difference between them which we will be seeing. So a gateway is basically a device or a hardware which acts like a gate among the network, and which keeps a check, or we can say which monitors, which is definitely monitoring the incoming and outgoing data. Incoming and outgoing data, the data which is entering the network, and the data which is moving out of the network. So it does the work of monitoring that data, filtering out unauthorized or unauthenticated data. If the data which is going out, that is confidential data which should not go out, it will block it. And if there is any unauthorized access from outside into the network, it will also block that. And basically its task is protocol conversion, that is it also connects very dissimilar networks together. How there are systems which are completely different, even the network configuration is different, the type of systems is different, even the protocols are different. So what it does is it does the work of protocol conversion. The basic task of gateway is protocol conversion, and this protocol conversion is not done by routers, students. Okay, of course it can connect protocols different up to certain degree, but it doesn't perform protocol conversion. But gateways perform protocol conversion because they work at the highest level of the OSI model, which we will be studying in the next chapter, which is actually a model, a standard which has been created for the working of internet. Okay, so this OSI model is it consists of several layers, and gateways are devices which work at the topmost layer of this model. Okay. So gateway uses more than one protocol for communication, thus its activities are much more complex than a switch or a router. For any kind of workplace, the gateway is a computer system which is responsible for routing the traffic from main workstation to outside network. And for homes, it just acts as a device which provides us access to the outside internet. That is, it is the internet service provider or the ISP's server which acts as the gateway for us. That is all the home users. So it connects dissimilar networks. It operates at the highest layer of network abstraction, expands the functionality of routers by performing data translation and protocol conversion. And let's see the example like Ethernet traffic. The systems which we are using, they are basically Ethernet. Ethernet is a standard which was created by IEEE, that is Institute of Electrical and Electronic Engineers, and that was done for all these microcomputers. And so any kind of network here will be known as LAN. Now we have IBM's SNA, Systems Network Architecture, which is completely a different network, which has a different configuration and it follows a different protocol. So gateway allows communication between these two dissimilar type of networks, but routers don't do that. And then mainframe architecture also, so it allows protocol conversion from, sorry, one second, protocol conversion between various systems. So next is we have we can say over here you can see on premises data gateway. So this is a thing, something which is related to any company, any enterprise, normally large companies which have their own personal internet, which is also known as intranet. They have that, it's not their personal internet, means it is their personal network which is known as intranet. An intranet is a network which is very specific, which works similar to the internet, which uses all resources of internet, but it is private to a particular enterprise, to a particular organization. Okay, so intranet is what which is confined within the company. So it is quite possible that there are servers inside which contain confidential information, and hence that information has to be protected under all circumstances. It has to be protected from outside unauthenticated access also, and also it has to be protected such that no such data leaks out of the intranet. Okay, so there is a gateway in between, which could be a computer or a separate device which is a dedicated gateway. And what it does is it monitors, it just keeps a watch on the incoming data and the outgoing data. That is the task of it, and hence it acts as a gateway. It can also, it does protocol conversion also, but its basic task in enterprises or companies is to keep a watch or monitor the incoming and outgoing data packets. So acts as an entrance to another network. In enterprises, gateway is the computer that routes the traffic from workstation to the outside network that is serving the web pages. Now let me just explain you one very nice example of this. Many a times when you book tickets online or purchase something, you need to perform online monetary transactions, isn't it? Online you perform monetary transactions. So for doing that, you might have sometimes seen it is redirect, you get a message like this, redirecting you to the payment gateway. Aisa aata hai message, right? So this message takes you actually what the app, the mobile app from where you are placing an order, and which is actually connecting you to this gateway. They are using an API, an application program interface of the bank, right? And the what API is, it's like a junction point, it's like a small window which only allows you to access or just allows you to use that feature of the bank, but it will not give you complete access to all the resources of the bank. Okay, how transaction is done, how things are done, bank will provide this API to you, right? How it is actually doing it, you don't need to know that. You just need to implement that function inside your app, and your work will be done. So what happens, it just takes you into that payment gateway which does a lot of monitoring. It asks you for your debit card or credit card number. It will ask you for your CVV numbers. A few years ago it used to ask for the PIN number, but now almost all websites, they ask for the CVV number, which is a 3-digit number printed at the back of your debit card. Because I don't have a credit card, I have a debit card, so I would be able to tell you more about the debit card. Okay, and then it also sends some authentication information, some verification, it does some kind of a verification also, like it would send captcha to your phone, or sometimes it would also send an OTP, or sometimes even both. So with this, only after checking that your information is coming from an authenticated source, then only it allows the transaction to take place. Okay, so that is what it is, a gateway which is actually acting as a monitoring agent, and which is monitoring everything which is entering inside the network or going out of the network. And gateway at home, so you can just see this is a home network, and what all things are connected. Two PCs are connected, there is a phone connected, there is a television connected to it. And residential gateway, which is actually your modem router which you are using, that acts as your residential gateway, which is actually connected to the ISP's router. And hence this entire thing, you can just call this entire thing as the gateway. Okay, so it is just connecting you with a larger network, and also some kind of authentication is applicable even there. Next is proxy server. Now what is a proxy server? Sometimes what happens is, when I want to block certain things, if I want to block certain things, like before joining your school, I worked for 1 month in First Source. It, I don't know whether it's still there in operation or not, but they were an outsourcing company which provided services, which provided these BPO services to Airtel. So I was there in the voice process, and there I took training for 1 month. And actually that time we were, there was recession, it was 2009, and there was a recession going on. So many of our friends also, we didn't have any job at that time, so we thought that okay, let's just join this, and in the meantime, if we get a good job somewhere, we will join. So we had joined First Source, and there they had some kind of a proxy server. It is actually not exactly a server, it is kind of a, it is a system which acts as a proxy, a substitute server. Okay, so what it does is, it monitors everything what is going on inside the network. So they had an intranet, and this proxy server used to monitor everything inside that intranet, and even it keeps a check on the websites which you are accessing. We couldn't access any social networking sites, we couldn't access any unauthenticated sites. Okay, there were only few things, like we could access Google, we could access our Gmail account, and that's all, and the Airtel uh, website. Only these few websites were allowed to be accessed by any employee over there. So proxy server is not exactly a server, but it is a substitute server which is connected to the actual web server. It could be any web server, not necessarily Facebook. So like you can see, there is a school PC. Some student is sitting there, and students sometimes they may like to just access their Facebook account. So what happened? They would send a request, they would type www.facebook.com, and the moment they press enter, it means they are placing a request to the server. So this goes to the firewall, and the firewall blocks this request. Okay, and usually proxy servers are coupled with a firewall also, which keeps a check on the incoming and the outgoing data. So now what happens over here? It allows it for whatever request you are sending, it will first go to the proxy server. The proxy server will check whether it is a proper authenticated, because already some requests have been blocked by firewall. Even if the firewall allows it to pass through, it will reach the proxy server, which will check whether the request is authenticated or not and authentic or not, and then it will forward that request to the server. Server will serve the request in the form of a response, which is usually in the form of a web page, and that comes to the proxy server. Proxy server sends it back to the computer. So this, the gateway node in enterprises, it often acts as a proxy server and a firewall. So that is basically done to block unauthenticated requests from outside, and also to block any bleeding of data into, or any leaking of data, confidential data or important data out of the small network, out of the private network. Then we come to wireless access point. You can see in this small image the wireless access point. This is actually your Wi-Fi modem which you are using. Why Wi-Fi? Because already it's the term wireless, and usually nowadays you will mostly find the wireless access points everywhere. Now what can you connect to it? It also has the LAN ports through which you can connect an Ethernet cable, right? So it allows you that also. Like at my house, I have a Wi-Fi modem. I have a desktop PC which is connected via Ethernet cable to this modem. Okay, because of obviously it is a desktop and I don't have a small Wi-Fi adapter. Hence, it is attached through cable to my Wi-Fi modem. And I have a laptop which is a wireless device. I have two smartphones which are also wireless devices, right? And I can connect all those devices, all those wireless devices, using the radio frequency signals which are emitted by this Wi-Fi router. And you can see over here, this is a small LAN consisting of three computers which are connected through guided media to this 10 base T switch. Now 10 base T means it is a standard for cables, right? So it's a standard for coaxial, or it is a standard for coaxial cables, right? So this thing is like, you can see this is a switch which is connecting these three computers. So this is a LAN, and this wireless access point is actually providing access to the outside internet to all these devices. So it establishes connection of computing devices on wireless LAN with a fixed wired network. It then broadcasts wireless signals that computing devices with Wi-Fi cards can detect. So all whatever I explained to you, it's there, and its range is usually up to 150 feet for home-based APs, and sometimes if obstruction or interference is less, in that case it can even shoot up to 170 feet. Okay, so this is what is wireless access point. With this we complete the network devices, network hardware part. More are there, so we will be seeing that in subsequent slides. What are the advantages? Easier installation, easier maintenance, bigger network coverage, stable signals, ease of work. Next, very important, cloud. Okay, last year also you people had some part of the cloud, right? Just let me see. You had some part of cloud, right? It was in very short. Now also it's not given in a lot of detail. right? But only some parts are given, only they have touched the topic. So that much is sufficient for this level, although you can also try to gain more information about this. So what is a cloud? Everybody already knows, people have been using this cloud platform, cloud software. So what is a cloud? Even our school is using a cloud software, that is School MIS, where all the students, all the teachers, faculty members, they can access their own personalized accounts using this School MIS. Sitting at their home, we can enter the marks into the School MIS sitting at home. Earlier, there was a requirement that we had to be present at school, and the first lab, the lab one, that was only suitable for mark entry. So we had to, there was, caused a lot of rush over there. But sooner, what happened that these people, the Adonai people, Adonai Technologies, they shifted to a cloud platform and they created this software. Basically, cloud is not something rocket science, but it is usually your servers, large servers which store data. And not only they store data, but they provide services. They can provide services in the form of hardware and networking equipment to you. They can provide services in the form of data storage to you. They can provide software to you, right? They can provide you access to certain applications to you. So these are various facilities which are provided by cloud computing. Normally, those companies which have which provide these cloud computing services, they have large data centers which are installed at various places. Okay. In our country also we have data centers at various places, right? Specifically in Mumbai. And then you have large cities. Usually it is large cities in at places. Okay. And usually the capital cities or commercial capitals of cities, of commercial capitals of countries which have these data centers. There are some companies which are providing this. Google is providing it. AWS, Amazon Web Services, Amazon is providing this, right? And various other companies which we would be seeing. Microsoft Azure, it is also a cloud computing company. And so we are also, it's a part of your Microsoft only. So we will be seeing various such companies which are providing these cloud platforms or cloud services to customers. Okay, so let's move on. So in bigger networks or WANs, there are multiple servers. Now, I was talking about this data center. So what are data centers? So data centers are large places like large warehouses, and they have a lot many racks and cabinets which would be kept one after the other, and each of them has a lot of trays which contains your hard disk, its processor, lot many processors, lot many hard drives for storage, and also RAM, right? So there is a, you can store a lot of data there. You will also get access to the latest hardware and networking devices there. So all these services, all that is stored in a data center. Actual storage and work happens here. Now, when you are storing something on a cloud platform, you don't know which data center it is going, unless and until the service which you are taking. Like right now, when I am trying to store anything on Google Drive, it is also being stored on a cloud. But where, in which data center? Maybe in any data center in our country it is being stored, or it might be getting stored somewhere else. But usually what happens is, the nearby data center, the data center which is closest to your computer, that is basically chosen for this purpose. So actual storage and work happens here, placed at safe, secure, isolated places. End users work on their workstations at other places. So it's just like a storage for us. But it won't cause a lot of pressure or load on our computer, on our hard disk. We can easily keep on storing things on from our computer to the cloud, to our cloud storage. We might now see, when you have any access to cloud storage, if you are using storage as the service there, so you will be getting a limited amount of space. Okay, like Google Drive already provides you around 15 GB of free space. If you want more, you will have to purchase the space, right? So I can keep on, I think 15 GB is mostly sufficient for most people. So we, what we people do is we just keep on uploading all our photos, documents, everything onto our Google Drive account, and our system is not overloaded with data. You can just see what is there in the cloud. So we have servers which are there, and it can provide various services like virtual desktop, software platform, application storage or data. Virtual desktop means, if suppose I right now I am working on a Windows platform, but I want to create an application on a Linux platform. What I can do, I can just subscribe some service from a cloud computing company which will provide me a virtual desktop of Linux based system. Okay, so it is not exactly present on my computer, but I am able to see it on my screen. So that is a virtual desktop. That is, it provides me an emulation kind of, where I am getting an illusion that I am working on Linux, but actually it is coming from a data center. Software platform, that is, I can work on any type of software on that. There are various cloud softwares which are available, right? I can work, I can access applications, I can even work software platform usually for any development purpose. I can develop something, I can build something using that. I can access applications which are cloud based applications. I can access storage and data. And not only that, but I can also access infrastructure. Now there are, one second, two things associated with cloud. One is IaaS and one is SaaS. This is known as infrastructure as a service, and this is software as a service. So these are two very important services provided by cloud computing, where the first one, you can use the hardware and the networking devices as a service from the cloud platform. Like for example, I don't want to keep purchasing a latest computer, or a computer with the latest configuration or high configuration every time, because we know that every 6 months or every 3 months a new processor is introduced. Okay, when I had purchased this laptop, it was i5 8th generation. Now we have 10th generation, i5 10th generation, and even i9 has been introduced. मैं कितनी बार computers खरीदूंगी? So that is why what I can do, if I have access to internet, I can just use IaaS, and from there I can easily use the latest hardware and networking devices for my PC or for my office setup, whatever it is, right? For home use, personal use, or whether it is for any company use, I can do that, but I'll have to pay. It will not be a free service. I'll have to pay some money for that. And second is software as a service, that I can use any cloud software. These days, many softwares are there like Adobe Creative Cloud CC, Adobe Creative Cloud, Adobe CC. So it is also a cloud software. You can use it as an online service also, or you can just install it on your computer and use it. And Office 365, which is also a cloud software, you don't need to install anything on your computer. You can directly just type office.com. Like, I'll just show it to you right now. I'm switching on my Opera GX browser. I've I'll not lie to you. I have again, although I had a science background, I had PCM in class 11th and 12th, but it's been a long time. So again, I am getting back to all those things because in the next chapter, computer networks 2, we are going to deal with certain things related to radio frequency. So we'll have to study things related to frequency, what is the cycle, okay, what is amplitude, right? Because we need to, the first topic is modulation techniques. So all those who are not from the science background, it's my request to you, please start at least start figuring out those things, right? Although I will be I'll try to keep it as simple as possible for both the streams, right? But I want you people also to put some inputs from your side, right? So I was learning all those things, I was actually just refreshing all those things. So you could have, you might have seen those tabs which were opened here. So I'm just going to open office.com. So this is office.com. And because all of us have an office, Microsoft Office account, we all have a Microsoft ID, right? So you can see over here that I am logged in through my Microsoft ID, which has been provided by Montfort School. And on the left hand side, you can see there are so many different tabs where I can use Word online, Excel online, PowerPoint online, Outlook online. I'll just show you how we can use Word. So this is it. You just click on this and click on new blank document and it just opens. So I don't need to have a MS Word or MS Office package installed on my computer. I can use everything online over here. So this is an example of software SaaS. Now because I am using a Microsoft account, so some features are free for me, but some features will require some purchase, right? So that is also there, that always a constraint with Microsoft because it provides it creates proprietary softwares which are not available free of cost. So we are connected using a network device. So you can see what all things are connected. We can connect printer, laptops, smartphones, tablets, anything. We can use it anywhere. Even cloud print, that is, I can just, I don't need to attach a printer. My printer is in my office and I'm sitting at home. I can just give a print command, and if that printer is on, if it is connected to a computer or if it is connected to a modem or Wi-Fi device there, and if it is on and if I give a print command, my document will get printed over there. A network device where we can connect different computers or workstations together. So this is, it was actually a diagram from your textbook only, but I just modified it with some animated GIF images. Types of clouds: private cloud, public cloud, community cloud, and hybrid cloud. Now is private cloud. First of all, just take a look at all the companies. They are not all the companies, it's just a few of them which I have listed over here. These companies provide, normally they are working in the fields of hybrid cloud because hybrid cloud uses the features of private as well as public clouds. Now what is exactly private clouds? Private cloud is a separate cloud computing data center which is created, maintained and managed by a particular company for their own internal use. मतलब इसको और कोई यूज नहीं कर सकता है, इसे केवल वो कंपनी यूज कर सकती है. So either that company can create its own data center and use it and maintain it, but what will be the, I mean, what do you think would be the disadvantages of doing that? Firstly, if that company has its own data center, it has to hire staff, expert staff for managing that data center. So their salary is one of the issues. Maintaining and managing this data center requires a lot of hardware, which is again something which is very expensive, so they'll have to invest a lot of money into that. So there is a lot of hassle which is involved in keeping our own data centers. Instead of doing that, These companies, they provide private cloud services also, public cloud services also, and some of them provide public cloud services also, some of them provide hybrid services. So like HPE, Helium, Microsoft Azure, Red Hat Cloud Suite, Dell, they all, VMware, Oracle Cloud, most of these, like HPE provides hybrid cloud, that is public and private cloud also. Red Hat, Microsoft Azure is also dealing with private cloud and hybrid cloud. Oracle also is dealing with private and hybrid cloud. So what happens is, if you use their services, they will guarantee that सब कुछ उनका होगा, डेटा सेंटर भी उनका होगा, सारा सर्विस भी वो लोग प्रोवाइड करेंगे, स्टाफ पर्सनल उनका होगा. So but you will have, that company will only have to pay for the services, right? But everything would be like a private cloud only. Everything would be private, that is, they will have their own personal, although what should I say, they will be having, they will be using everything, the company would be using everything as if it is their own private cloud, because they will be needing a particular authentication process for doing all this, right? So either a company can set up its own cloud, or it can take services from these companies in order to manage a private cloud. Now, what this private cloud will be, there are extra security features which these companies provide. Okay, they guarantee that data will not leak out from their own particular domains. Okay, data will not leak out, and data would be safe from any kind of unauthorized access from outside. And no, means everything will be similar to that only. And in case there is any such incident of data leaking out, these companies would be totally responsible for that. So यहाँ पे भी company का headache बच गया, right? And all they have to do is they just have to pay the money to take their services, right? So this is it. So this private cloud is basically for, it is maintained by a particular company and for their own task, for their own work. It is not shared by outside people, right? So that was private cloud. In the next class, we will see public cloud, community cloud, and hybrid cloud. So I hope you all understood today's class. So we end today's class over here.